11.9 asks us to look at this graph and to use it to answer the following question. How much heat is required to heat 11 grams of ice at negative 13 degrees Celsius to 36 degrees Celsius? The first most useful step is to look at this graph and plot what happens to our system as it goes through gaining heat. So we start down here as ice. We're at negative 13 degrees Celsius. To get from A to B, we have to gain energy. That's going to be step 1. Step 2, we have to gain energy and undergo a phase transformation. And then step 3 has us going all the way up to 36 degrees Celsius and then stopping there. So if we look at this problem in terms of each of these individual steps, we can calculate how much energy is needed for them and then add them together at the end. Looking first at step 1, we see that we're going up on a diagonal, and so we're going to use Q equals mc delta T. So we'll find that Q is equal to our 11 grams of ice times the specific heat of ice in the solid phase, so 2.087 joules per gram degree Celsius, multiplied by the change in temperature, which is 0 degrees, which would be our melting point, minus the original negative 13 degrees Celsius. This value ends up being 298.441 joules. Next, we want to look at step 2, which is this phase change from solid ice to liquid water. For phase changes, we have to use values like the heat of fusion. So this is when you're going from solid to liquid or vice versa. In order to use this value, it's in kilojoules per mole. So we have to know how many moles of water we have. So our grams cancel out. We convert moles using this kilojoule per mole conversion. And then because our first value was in joules, I want to cancel out kilojoules and convert it to joules instead. So our final answer here is 3,678.889 joules. Step 3 is our last part, where we're climbing the curve right here to stop at our final temperature. We're going to use Q equals mc delta T. So Q will be equal to our 11 grams of water, multiplied by the specific heat of liquid water this time, because now we're in the liquid phase. And then we're going to multiply that by our final temperature minus our initial temperature. And if we do the math, we end up getting 1,656.864 joules for step 3. Now our final step is just to add all these energies together. And if we do so, we end up getting 5,634.194 joules. This is a really large number, so it would be better reported in kilojoules. So we divide it by 1,000. And we get a final answer of 5.634 kilojoules. Looking at our significant figures, we see that we had 11 grams of ice reported here, and so this should be reported to 2 sig figs.